The most important aspect of creating a great iPhone app is exploiting the iPhone's features. One of the keys to creating a great app is taking advantage of what the device offers. In the case of a platform with new possibilities, such as the iPhone, this is especially important. Think about the possibilities that open up to you when your app can easily do the following: access the internet, make phone calls and send messages, know the user's location, track the action of the user's fingers as they touch the screen, play audio and video, access the user's contacts and calendar, access the user's photo library and cameras, copying, cutting, and pasting among applications, and multitasking, providing background processing, and also providing notifications. So let's go over these one by one. Accessing the internet. The ability to access websites and servers on the internet gives you the ability to create apps that can provide real-time information. An app can tell you, for example, that the next ferry trip to Alcatraz in San Francisco is at 3 p.m. This kind of access allows you, the developer, to go beyond the limited memory and processing power of the device and access large amounts of data stored on servers. Your app doesn't need to store all the information for every city and tour schedule in the world on your iPhone. Your app can send the request to a server and have the server do all that work, especially for information that changes often. This is what we call client-server computing. It's a well-established software architecture in which the client, in this case the iPhone app, provides a way to make requests to a server on a network. The server is out there just waiting for the opportunity to do something. A web browser is an example of a client accessing information from other websites that act as servers. HerePlanet, for example, accesses a database on an internet server to get all of its information. So does Showtime's, and so do many thousands of other apps. The Facebook client app accesses a very large network of databases. The next feature to talk about is making phone calls and sending messages. Your app can present the standard system interface for composing and sending an email over the internet and for composing and sending SMS messages over the phone network. Your app can also interact with phone-based information on devices that have a cellular radio, like the iPhone. That way, your app can get information about the user's cellular service provider and be notified when cellular call events occur. You can even access information about active cellular telephone calls and access cellular service provider information from the user's SIM card. The iPhone also makes voice over Internet Protocol applications a reality, such as Skype. In fact, you can now do the same things with Skype on an iPod Touch that you can do on an iPhone or a cell phone. You can talk to someone and use the apps at the same time, and you don't need any carrier service other than an internet connection. The next feature to talk about is knowing the user's location. The iPhone and iPod Touch offer location services that let you create an app that can determine the device's current location or even be notified when that location changes. As people move, it may make sense for your app to tailor itself to where the user is, moment by moment. The iPhone uses the Global Positioning System, also known as GPS, which is a satellite-based navigation system made up of a network of 24 satellites placed into orbit by the U.S. Department of Defense. The iPhone GPS hardware can determine its location without an internet connection. The iPod Touch and the Wi-Fi model iPad use Wi-Fi and an internet connection to determine its location, which is less accurate than GPS, but just as useful for an app's purposes. Many iPhone apps use location information to tell you where the nearest coffee house is or even where your friends are. When you know the user's location, you can even put it on a map, along with other places he or she may be interested in. Another feature to talk about is the ability to track orientation and motion. The iPhone contains 3 accelerometers. These are devices that detect changes in movement. Each device measures change along one of the primary axes in 3-dimensional space. An app can, for example, know when the user has turned the device from vertical to horizontal, and it can change the view from portrait to landscape if doing so makes for a better user experience. You can also determine other types of motion, such as a sudden start or stop in movement, or the user shaking the device back and forth. For example, the What's Shaking app uses this feature to give you a percussion instrument. The iPhone 4 and the newest generation iPod Touch includes a 3-axis gyro for detecting and measuring orientation. This combination with the existing accelerometers give the device what is called 6-axis motion sensing. That includes the X, Y, and Z coordinates for both the accelerometer and the gyroscope. Your app can work with both raw accelerometer and gyroscope data and with processed device motion data, which can include the accelerometer data along with rotation rate and attitude measurements. This kind of data is the basis for many games, as well as for the shake to undo feature of the iPhone. And you can use it to make some way cool features, such as using an Etch-a-Sketch type metaphor to shake the device to reset your app, or for controlling a game by moving the iPhone like a controller. Probably the most important feature is the ability to track the action of the user's fingers. People use their fingers rather than a mouse to select and manipulate objects on the iPhone screen. The moves that do the work, which are called gestures, give the user a heightened sense of control and intimacy with the device. Several standard gestures are available. For example, you can tap to press or select something, like a single mouse click. You can drag to scroll or pan, which is to move side by side, and you can flick to scroll or pan quickly. Other gestures include swipe, which is like a flick, but in a table view row, it reveals the delete button. A double tap can zoom in and display a block of content or an image in the center, or it can also be used to zoom out if you've already zoomed in. Another gesture is the pinch, which zooms out, for example, in the Maps application. You can also unpinch, which is also known as pinch open, in order to zoom in. Another useful gesture is to touch and hold to show a magnified view of editable text for cursor positioning. And you can also shake an iPhone to initiate an undo or redo action. I strongly suggest that you use these standard gestures in your app as they were designed to be used. Even so, the iPhone's multi-touch hardware and software allow you to go beyond standard gestures when appropriate. Because you can monitor the movement of each finger to detect gestures, you can create your own, but use that capability sparingly, only when it's undoubtedly the right thing to do in your app. Another great feature of the iPhone is playing audio and video. iOS, the operating system for the iPhone, makes it easy to play and include audio and video in your app. Your app can even stream that audio and video wirelessly to an HD TV set using the AirPlay-enabled Apple TV. Apps can play sound effects and even take advantage of multi-channel audio and mixing capabilities to mix music from simulated instruments such as guitars. Apps can also play back many standard movie file formats, configure the aspect ratio of the video, and specify whether controls for the video should be displayed. This means that your app can not only use the iPhone as a media player, but it can also use and control its own content, such as scenes from a game, and stream them to a user's HD TV set. You can even create your own music player that has access to all the audio contents of the user's iPod library, and you can stream the music to any AirPlay-enabled receiver or speaker system, or the Apple TV. Another cool feature is the ability to access the user's contacts and calendars. Your app can access the user's contacts on the iPhone and display that information in a different way, or use it as information in your app. What's more, your app can also present standard system interfaces for picking and creating contacts. And what you can do with contacts, you can also do in a similar fashion with the calendars in the user's calendar app. Your app can remind a user when to leave for the airport or create a calendar event based on what's happening this week in London. These events show up in the calendar app and in other apps that access the calendars. As with contacts and calendars, your app can also access the pictures stored in the Photos library on the iPhone, not only to display them, but also to use or even modify them. For example, the Photos app lets you add a photo to a contact, and several applications enable you to edit your photos on the iPhone itself. You can also incorporate the standard system interface to actually use the front and back cameras as well to take pictures and record video. And you can record and edit HD videos. Check out the iMovie app from Apple, which runs on the iPhone and the iPad too. Any app that deals with text should also use the ability to copy, cut, and paste with other apps. iOS provides the functionality for copy, cut, and paste operations within and among applications. It also provides a context-sensitive edit menu that can display the copy, cut, paste, select all, and delete system commands. So, although each iPhone app is generally expected to play only in its own sandbox, you do actually have ways to send small amounts of data between applications. There is one more important feature to consider, and that's multitasking, along with background processing and notifications. Although iOS doesn't really offer true multitasking, in fact, devices need multiple CPUs or multiple cores to offer true multitasking, it does have instant-on task switching that reduces application startup time and makes it easier to continue right where you left off. For certain kinds of apps, you can also process events in the background. For example, applications that play audio can play it in the background. Applications that process location events can also process them in the background. A location event is when iOS sends your app changes in location. And finally, an application that lets you make voice over internet calls can also allow background processing to monitor calls coming in. What you can also do in your app is post local notifications as a way to get the user's attention when important events happen. For example, a driver navigation app running in the background can use local notifications to alert the user when it's time to make a turn. Applications can also schedule the delivery of local notifications for a future date and have those notifications delivered even if the app isn't running. So it's important to remember to include as many or all of these features in your app and to really take advantage of the iPhone's feature set.